Geometry students, this is Miss Green, and we're going to go on to 6.4 where we're going to prove that a quadrilateral is a parallelogram. Here are our learning targets for both days. We want to be able to demonstrate that a quadrilateral is a parallelogram based on its sides and diagonals, and demonstrate that a quadrilateral is a parallelogram based on its angles. Let's look at this example. In this example, we have a quadrilateral because it has four sides, A, B, C, D. We know AC is a diagonal. We know AB is congruent to CD, and notice they marked that for us, so that's great. Let's see, I think I'll do purple. Yeah, so we have this one. It's congruent. AB is congruent to CD, and AD is congruent to BC. Now we want to know if it's a parallelogram. Well, somehow we have to, by the definition of a parallelogram, we have to prove that the opposite sides are parallel. I'm going to start by looking at the triangles. Can I prove that ABC triangle, ABC, is congruent to triangle CDA? Look what happens when I do that. They have the same side, right? So they're sharing this side, and that side's congruent to itself. Now I can see just by looking that I can prove the triangles are congruent by side, side, side. Now somehow I can prove then that this angle is congruent to this angle. Then I know that those are alternate interior angles, and if they're congruent, the lines must be parallel. But how can I prove those angles are congruent? Well, that would be with my CPCTC. Now, how can I prove opposite sides are parallel? Well, I just said the alternate interior angles are congruent, so they must be parallel. That's from way back, right? First part of the year. And then how can I prove a quadrilateral is a parallelogram? Well, I proved those were parallel. These two are parallel. I could do the same thing with with this angle being the same as that angle, again by CPCTC, and then now we have these lines where that's the transversal. So now those two sides are also parallel. And so how can I prove a quadrilateral is a parallelogram? I've proven that the opposite sides are parallel. And it's kind of a rough proof, but I didn't write out every single step. But we got the basic idea. Now I want you to try this. Look at this quadrilateral and explain why you cannot conclude that ABCD is a parallelogram. Try it and then we'll come back. When I think about all the things that I know that are true about a parallelogram from the previous day, I know that all these things are true. Opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So when I look at this one, and I look at the opposite sides, this is opposite to this, I can see that they're not congruent. And then I could say the same thing with this one. This is not congruent to that one. So that's enough information. You just need one pair that's not congruent of opposite sides, and you can say it's not a parallelogram. Doesn't fit the definition. The converse of Theorem 6.7 states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So this is the converse of what we did in the previous section. The previous section said if a quadrilateral is a parallelogram, then its opposite sides are congruent. So now we're saying we don't know if it's a parallelogram, but we do know opposite sides are congruent. So if we know this, and they see how they marked, this is a really good way to write out your theorems. If you have words, I always put pictures with my words. And I have a big if statement here, I have a diagram, and then I have the then statement here. And sometimes, too, you might see that I would write out parallelogram to shorten it a little bit to look like that. Now, so we know that's true about opposite sides. Let's look at angles for a minute. Teal sketches a design of a quadrilateral shaped building. So it's got 4 sides. If angle 1 is supplementary to angle 2 and angle 4, and we figured out that those must be the same, but if they're supplementary, is his design a parallelogram? And I've put a lot of these think about it's over here because we have so many things going on. It helps to kind of write down things that we know and we want to know and some strategies that we know are true. So what do we know about lines if the same side interior angles are congruent? Well, that's something to think about right there. And then same side interior angles. Oh, you know what? I made a mistake here. I didn't want congruent. I went supplementary. That makes more sense because that's what it's telling us. And then, so if we had 2 lines, like this line and this line, and we know that these are same side interior angles because here's my transversal. We know they're supplementary. In other words, the measure of angle 1 plus the measure of angle 4 equals 180. What does that tell us? It tells us, I'm just going to call this line A and line B. It tells us that line A is parallel to line B. I'm going to go for a different color here. But we also know that 1 is supplementary to 2. So then we're looking at these 2 lines, where this is my transversal, and I'll call this line C and line D. Now we know, because the measure of angle 1 plus the measure of angle 2 is 180, we're given that, we know that line C is parallel to line D. So we've identified same side interior angles, and we've been given that they were supplementary for both of these. So opposite sides are parallel, and if opposite sides are parallel, then it is a parallelogram. And I'm going to write parallelogram like this. Wonderful. Okay, here's another example where we're looking at some angles. This time we're saying angle 1 is congruent to angle 3, and I will always just write on my diagram. If you don't have your notes handy or printed out, you could redraw it, but you always want to make notes on your diagrams because it makes it so much easier to interpret what's going on. It also says 2 is congruent to 4. Now, is that a parallelogram? Well, I wrote on my diagram everything I know. Here's a strategy. Some call it KWS, where S is strategies, but I was thinking with geometry, I'm always writing out what's true, what's true, what's true. In other words, theorems that we know or other things that we've learned along the way. So I would want to write out here everything I know, and I have it in my diagram, but I'm just going to go angle 1 is congruent to angle 3. This is just a graphic organizer, some way to help you organize your information. And 2 is congruent to 4. Now, what do I want to know? Is it and again, I'm shortcutting a little bit, a parallelogram. Now, some strategies, and this is strategies, or I might make up my own strategies and call it a KWT, because truths, what do I know is true? So here's some things we can look at when we're trying to figure this out. This one takes a little bit of thought process to get it all figured out. Here's some things that I know are true. The sum of the angles of a quadrilateral is or equals 360. We learned that way back, right? 4 sides, 360. Okay. What else do I know about same side interior angles? If same side interior angles are supplementary, then the lines are parallel. Well, I wonder if I can somehow put these ideas together and show that this is a parallelogram. Well, the sum of the angles. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180. No, 360, sorry. Okay, now I know that 1 and 3 are the same. So I'm going to substitute and put measure of angle 1 here, and I know 2 and 4 are the same. So I'm going to put measure of angle 2 here. So now I've got 2 of these, the measure angle 1 plus the measure angle 2 equals 360. And I can divide by simplifying. And I could say the measure angle 1 plus the measure angle 2 is 180. Well, that's kind of nice. I could also substitute, so 1 and 2 are 180. So if these are 180, then I have same side interior angles that are supplementary. Now, what I know, 1 is the same as 3, so the measure angle 3, plus 2 is the same as 4, measure angle 4, is also 180. And I just substituted those in. So these are 180. Well, and if 2 is the same as 4, I could say measure angle 3 plus the measure angle 2, right, is 180. So then I could say these are supplementary. I could do the 1 and 4 too the same way. So now that I found supplementary angles here, and they're same side interior, I know that the opposite sides are parallel because of this one. And if both pairs of opposite sides are parallel, it is a parallelogram. Woohoo! Yes, yes, yes. Okay, you try this. Look at this diagram and see if it's a parallelogram, and I'll stop it and then come back and we'll talk about it. Quite a little work here. There's different ways to do this and different strategies, and you might have done something different. I know these 3 angle measurements, and I know if I add these 2 consecutive ones or these 2 consecutive ones, I would get 180. And then I also know that if same side interior angles are supplementary, the lines are parallel. So because these are supplementary, this is parallel to this. And then with another color, we could show that because these are supplementary, and these would be same side interior here, that these 2 would have to be parallel to each other. And by definition, this is something else I know, if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. Here's another one to try. See if you can explain why this is or is not a parallelogram. So if you looked at what do you know all these angle measurements, what do you want to know, is it a parallelogram, and what do you know is true about consecutive angles of a parallelogram? We've looked at that and we know that they have to add up to 180, they have to be supplementary. So when I add those up, I do get 180, but when I add these two up, I got 182. So the minute you find something that disproves your initial statement, then you know that it's not. So this is not, because these are not supplementary. All consecutive angles are not supplementary. All right, and we're going to summarize these two things that we've learned through some more theorems. This is the converse of theorem 6.8. So this says, if an angle of a quadrilateral is supplementary to both of its consecutive angles, so in this case we're going to look at angle 1 and we're going to look at angle B, and we know that those add up to 180, and then we also know that these add up to 180, A and D. So we can say it's a parallelogram. So this is one of the theorems that you'll need to remember. And you don't have to remember the number as much as what the statement is. So I wouldn't expect you to remember theorem 6.12 or converse of theorem 6.8, but I would expect you to remember what it says here that is true. And the same thing with this one. This one states that if opposite angles, both pairs of opposite angles are congruent. So B is congruent to D, and C is congruent to A. Both of them have to be congruent for it to be a parallelogram. And here's a quick little example. So what do we know about opposite sides of a parallelogram? Well, we were told that if these are congruent and this is congruent, then it is a parallelogram. So what values of R and S in W, X, Y, Z, for what values is W, X, Y, Z a parallelogram? So for that to be true, the opposite sides have to be congruent. And you would just simply set up your algebra statement, the math statement that says what the diagram says. And you guys have done enough algebra that you're probably getting pretty good at it. Sometimes I combine it all in one. And sometimes I don't show this step because I know right off how to do that. And the more you do it, the more you practice it, the easier the algebra gets. So S plus 5 has to equal 2S minus 2. So I'm going to subtract S from both sides because I don't like messing with negative numbers. So I have 5 equals S minus 2, and I'll go ahead and add 2 to both sides. And S equals 7. So with those two numbers, S equal to 7 and R equal to 2, I could substitute those back in there and I could see what the actual measurement of the sides are. And then I could verify that they are congruent to each other, and so it must be a parallelogram. Here's another example with angles. And do you remember what's true about opposite angles of a parallelogram? We know that these two must be congruent to each other, and these two must be congruent to each other. So set up your math statements and solve for A and solve for B. And then I'll be right back. Get A equals 7 and B equals 36. And again, you could put these back into, so 5 times, oops, you could do a little check. 5 times 7 is 35. And then 3 times 7 is 21 plus 14. That equals 35. So they're equal to each other. So, you know, those work. And then you could try the B also and see if that works. This is our last one for today. I want you to try this one. If G is 14, so I'm going to say, okay, I'm just going to write down here, G is 14, H is 5. Is it a parallelogram? You have a couple options. You could set up like we did before, set up the two sides equal and solve for yourself and see if you get the same numbers. Or you could just, what's the other option? Just substitute them in and see if it works. Try it. I substituted 14 for G. I did it over here and I found that 17 equals 17. So this was 17 and this was 17. But when I substituted 5 in for BC, I got this to be 6 and this to be 7. So if these are not the same, then it's not a parallelogram. All right, so go ahead and look at your Math Excel for today. And we're on 6.4. And you should be able to hopefully complete all those. You've taken some good notes and you have some references to help you through those problems. 6.4, Part A.